Hi, my name is Dr. Andrew Kaliuk, and I'm an assistant professor at Otterbein University. I want to talk real quickly about what agent-based modeling is and what an agent-based modeling class would look like. People hear computer modeling, and I think a lot of folks that don't have a background in the computer sciences can get a little bit hesitant from that. So I wanted to show you what sort of things you need to understand before trying to do an agent-based modeling course and how that might affect and help further your career. So the qualifications that you need are essentially nothing, right? You have to have a computer. Everything that you're going to be using in a agent-based modeling course that uses the program that I specialize in is free. In agent-based modeling, you're focused on an individual particular agent, and that agent can be a person, agent can be an animal, it can be a amalgamation of a bunch of different people that are all part of a single group. It could be a nation state, it could be a corporation, it could be a cow, or it could be a herd of cows that are interacting with other herds of cows. The agent itself is what you are going to be acting on. When you're talking about an agent-based modeling program, there's a lot out there. Mason and Swarm and Repast are certainly used in lots of other places, but the one that has gained a lot of traction lately and the one that I use and specialize in is NetLogo. NetLogo is a great modeling program to get into an introductory course if you have no background at all, because NetLogo was actually designed to be used by kids, right? NetLogo is a version, there was a language called Logo a long time ago that was basically a game. Kids would play this game and you would press a button and make the turtle, this little thing, the little robot guy here that we have, move forward, take one step forward, you press another button, it turns a few degrees, right? You're driving this little tiny robot. In agent-based modeling, they've actually taken that old computer language logo, updated it, and digitized it. So let's see what NetLogo actually can do, and then we'll talk about what you actually do to program these sort of systems. This is a really good introductory model to get you in the headspace of what NetLogo and what agent-based modeling can do. So in this system, we have these little tiny fluffy-eared rabbits that are going to be hopping around randomly based on a set of rules that we've given them. And when they come across a patch of grass, these little green sections, they're going to eat that grass. As that grass grows, and as there's more grass, those rabbits will eat that grass. The more energy that those rabbits acquire from consuming that grass, they're going to split and have little baby bunnies. Those baby bunnies will go on to eat more grass. If for any reason, maybe these rabbits overpopulate and they're going to have too many rabbits and they are going to eat all of the grass available, well, that's going to cause some of our rabbits to starve. So it makes this really simple system where you can actually see rabbits hopping around and you can see their population going up. Rabbits go up, grass goes down, grass goes up, rabbits go up, right? So this sort of very simple ecological system. We can take it up another step and we still have our grass and we still have our dirt, but instead of rabbits, we have sheep in this instance. And now we have another agent. We have wolves, and we've given these wolves these set of rules where they run around and try and eat our sheep. So the grass is eaten by the sheep are eaten by the wolves. If there's a lot of grass, that means the sheep are going to do well. If there's a lot of sheep, that means the wolves are going to do well. And they're going to go through these cyclical ecological cycles that most of our biology students are aware of. And this will run on and on and on and on until we can kind of mess the system up and cause the population to crash. So we can tweak and modify these things, and then, oops, we've wiped out all of our wolves. All of the wolves gone, sheep are going to become hyper abundant and over reproduce. We don't only have to be talking about biological systems, we could also include things like traffic rates. And this is just a very simple traffic grid where our agent in this case is a car. We can make this much more complicated and include things like genetic algorithms where we actually can program our agents to change or evolve over time. And in this system, we're going to have this little robot that goes around and picks up cans. And as it picks up cans, it's going to get better and better at picking up this trash that has been left. And as this genetic algorithm runs through more and more and more versions, it's going to get better and better at doing this, right? This is a pretty classic genetic algorithm. This is on the higher end of complexity. If we want to replicate some of these models, we have to start at the beginning. And we don't need a lot of computer modeling experience or even mathematical language experience to actually do this sort of work. Agent-based modeling and other forms of computer modeling are best performed by people with language skills, not math skills. Math is a part of it, if you want it to be, but really this is a language that we're learning. And luckily, because NetLogo is meant for kids, we're really learning a very simple language. So if we think about how this actually works, we can go and dive into the code. If I zoom in a little bit, this is a very simple and very polite language. If I want to set this system up, I press the Setup button. So if I press Setup, it clears all of the previous system and then spawns one little turtle right here, right? Remember, we used the robot that was in the 70s. They still use that nomenclature for turtles. So we just say create turtles 1. And we can give that turtle some information, and we can say set your color to red. Set color red. So when we spawn our turtle now, it's always going to be a red turtle. It's not going to randomly assign it. And I can say, all right, now that we have this turtle started, I can give it a go command, and I can start this model working. If I want to have this be really simple, one thing that I'll do is I will say, all right, when go runs, ask turtles. So ask all of the turtles that are out there, go forward 1 step. Go forward 1 step. So when go happens, every turtle is going to start making moves forward. We can even spawn multiple turtles. So if we can create turtles 3, we're going to spawn 3 different turtles that are all stacked on top of each other because we haven't given them any other rules. And every time we press go, they're going to take a step forward, heading off in their own individual direction. We can say, all right, ask turtles, go forward 1. And we can say set heading random 360. So every time these turtles take a step forward, they change their heading and randomly spin around in a circle, landing on a direction. So when we do that, they're going to be walking around a little aimless. They're not very directed. They're kind of spinning around. They're not really going any one direction in particular. Right? So this is a very simple set of code, but really for some of these other systems, it doesn't get much worse. Right? You're learning a language here. This isn't really a math-related system. With this skill, you have the ability to work in many different systems. This is a model trying to figure out how cheetah amyloidosis is caused, looking at historical data. This is another model looking at how many dogs do you need to sterilize on the Galapagos Islands. That's actually currently being used to inform decisions on the ground. And this is another system, just as a classroom example, that I use to illustrate the ideas of genetic drift, where we smash bugs, having those bugs having some genetic diversity that is destroyed by the selection process. And then when they repopulate, now the bugs look a little bit different. NetLogo is something that's been incredibly helpful to my career, and I'm actively looking for additional people to come work with me and help me in my lab. This is a skill that really allows folks to do that. And I hope that if this is something that interests you at all, you can give it a go, even if it's a little bit outside of your comfort zone. I guarantee you that this is going to be something that will work well for everyone involved. Come here, ghost. Chomp, chomp, chomp.